Before you even leave your house, Google Maps already knows there's traffic on your route. But how is that even possible? Is Google watching every car on the road, or is something much smarter happening behind the scenes?
Welcome to this explainer. We've all experienced this highly relatable everyday magic trick. Picture this. You hop in your car, you're running about 10 minutes late for a really critical meeting, and before you even pull out of your driveway, your map app proactively gives you a detour. It reroutes you down this totally random side street, completely avoiding a massive highway backup that literally just happened. It saves your morning commute, and honestly, probably your reputation. But how exactly does it do that? Well, that is the central mystery we're unraveling in today's explainer. How exactly does Google Maps see the future of traffic? Now, it's pretty natural to assume there's just this massive sci-fi network of traffic cameras watching every single road and beaming that footage back to some giant control room. But the reality is actually far more invisible, incredibly scalable, and quite frankly, brilliant.
Okay, let's dive right into this. We've all stared at this familiar interface, right? Just praying for that solid blue line. You see the blue indicating a nice clear path, the yellow giving you a heads up about a slowdown, and then that dreaded dark red showing bumper-to-bumper gridlock. But what's absolutely wild is that those real-time colored lines aren't being painted by a fleet of helicopters up in the sky. They are actually being powered by the very device you might be holding right now, the smartphone in your pocket.
Section 1. The Invisible Sensor Network, from helicopters to smartphones.
You know, before digital maps came along, tracking traffic was honestly pretty clunky. Back in the 1990s, we relied heavily on radio reports from traffic helicopters. And let's be real, that usually just meant by the time you heard about a traffic jam on the radio, you were already stuck in the middle of it. Then, in the early 2000s, governments spent millions embedding physical sensors right into major highways to count cars. But that was way too expensive to do for local streets. And then came this brilliant pivot in 2009. Google realized they didn't need to build any new hardware. Millions of people were already carrying GPS-enabled smartphones. By shifting to smartphone crowdsourcing, the maps suddenly came alive. Fast forward to 2013, with the acquisition of Waze, they added active human reporting right into the mix.
So the crucial point here is you are the map. Whenever you have Google Maps open with location services enabled, your phone is constantly sending tiny bits of completely anonymized location and speed data back to Google servers. Now, one single phone doesn't really tell you much, but millions of Android and iOS users all moving simultaneously, that creates a constant real-time pulse check on literally every single road across the entire globe.
Section 2. Feeding the algorithm, the raw data behind the map. To process global traffic in real time, you need a massive data engine. It's not just one single data stream we're talking about here, it's a giant fusion of information. The system constantly ingests all that passive, anonymized smartphone GPS data. Sure, but it blends that with decades of historical traffic patterns. I mean, it knows exactly how a Tuesday at 8 a.m. differs from a Saturday at 2 p.m. Then it layers on real-time human intelligence, like when Waze users actively flag an accident or a massive pothole. And finally, it pulls in authoritative data directly from local governments about things like scheduled road closures and speed limits.
Now, synthesizing this massive, multi-layered stream of data is definitely not something your standard computer can handle. It requires incredibly powerful cloud computing architectures and deeply complex AI algorithms. These systems have to process billions of data points in the blink of an eye just to make sense of all the chaos on the roads.
Section 3. The AI Prediction Brain. Predicting the future, not just the present.
Now, what's really interesting about this is knowing that there's traffic right now is the easy part, but predicting what the traffic is going to look like 50 minutes from now when you actually reach that specific highway interchange, that requires the AI to distinguish between two completely different types of traffic. On the left here, we have recurrent traffic. This is the predictable stuff: morning rush hours, seasonal holiday trends. The algorithms learn these patterns pretty easily. But on the right, we have non-recurrent traffic: sudden accidents, a random downpour, and unexpected road closure. According to transportation research, these non-recurrent events actually cause nearly 50% of all congestion. This unpredictability is exactly where the artificial intelligence proves its worth.
To solve this massive puzzle, Google partnered with DeepMind, which is an elite AI research lab, to utilize the technology called graph neural networks. Now, I know that's a bit of a mouthful, but in plain English, instead of looking at roads in isolation, this AI essentially treats the entire road network like a giant connected web. If there's an accident on a major artery, the graph neural network conducts spatial and temporal reasoning to predict exactly how those delayed cars will spill over and choke up the surrounding side streets 20 minutes later. It's fascinating.
Let's move to the next concept and see how this builds. To process the entire planet efficiently, the AI clusters connected streets into what they call super segments. Basically, it groups multiple adjacent roads together that share a lot of traffic volume. By analyzing a whole super segment rather than just one single street, the AI can instantly calculate how a jam on a primary highway will cause a major ripple effect. It sees exactly how it'll push frustrated drivers onto local roads, which allows the app to calculate the overall delay for the entire area in real time.
So, here is the exact anatomy of a prediction. Step 1, the system detects an anomalous slowdown from a cluster of smartphones moving just a little too slowly. Step 2, it instantly compares this live speed to historical norms for that exact location, time, and day. Step 3, the AI kicks in to predict the duration of the jam and its ripple effect across the entire super segment. And finally, Step 4, before you even see the brake lights ahead of you, it does the math and automatically suggests a faster alternate route mid-trip.
The integration of these advanced machine learning models has had a really profound impact over time. Take a look at the steep upward curve right here. This perfectly illustrates the dramatic improvement in ETA, or estimated time of arrival, prediction accuracy from 2017 all the way to 2025. Because these machine learning models are constantly ingesting new data and learning from their past mistakes, the whole system literally gets smarter with every single trip we take.
And all of this complex math leads us to one staggering number, 97%. Thanks to deep learning and global crowdsourcing, Google Maps ETA predictions are now consistently accurate for over 97% of trips worldwide. I mean, think about that. That is an astonishing success rate for predicting something as chaotic, emotional, and unpredictable as human driving behavior.
Section 4, Shaping the Smart City, the global impact of optimal routing. Pulling back for a macro view, optimal routing has massive effects, and this brilliantly illustrates why this technology matters far beyond just your individual morning commute. By minimizing the time millions of cars spend just idling in traffic, we're seeing significantly reduced global fuel consumption and lower carbon emissions. It also allows for faster, literally life-saving emergency service dispatch by guiding ambulances completely around gridlock. It enables adaptive tracking for public transit, and it even provides city officials with rock-solid, evidence-based data for much better urban planning.
But, it's certainly not without its challenges. We have to acknowledge this fascinating, kind of ironic phenomenon known as the feedback loop. When a routing app becomes so widely used that it automatically reroutes thousands of cars away from a congested highway, well, those cars don't just magically disappear, right? They're often pushed right onto quiet residential surface streets, accidentally overwhelming neighborhoods, and causing entirely new traffic jams. It's a genuine urban planning puzzle for the modern age.
Ultimately, what started as a super simple tool just to get us from point A to point B has evolved into something profoundly impactful. As one researcher perfectly summed it up, it's like an X-ray of urban life, showing where people actually go and when they go there. Crowdsourced data, when combined with AI, has given us an unprecedented, real-time pulse on human movement across the entire globe.
Which leaves us with a pretty compelling thought to end this explainer on. We've gone from radio helicopters to billions of smartphones acting as global sensors, all woven together by deep neural networks. So, as AI continues to evolve and essentially take the wheel, perhaps very soon communicating directly with smart traffic lights and fully autonomous vehicles, how will the smart cities of the future rewrite the rules of the road entirely? It's a fascinating road ahead for sure. Thanks so much for joining me on this explainer, and keep exploring.